pleased to introduce Drake Smith. He is almost a junior line. He's going to graduate in December. Drake is very interested in conservation biology and mostly in herptiles, that's not actually a word, reptiles and amphibians, which are herps, and which he took my class in general entomology last fall, which is very nice because I'm sure that the reptiles and amphibians appreciate eating the subject matter of that course, which is about insects. Drake wrote the best paper, one of the best I've ever read out of all of my classes, about the behavior of a very interesting little ant. And so, without further ado, it is all yours.
As she said, I'm Drake Smith. So my research is on the use of pheromonal trail laying in the foraging behaviors of L. niger or Lasius niger. So my thesis of my research is we will discuss Lasius niger, a social species that sees foraging as a group effort. They will make efforts to both lay pheromone trails to affect the food sources and control the amount of crowding of resources so that optimum efficiency is reached for foraging. It's a mouthful, but let's break that down. So an overview of Lasius niger or L. niger. They are also known as the common black garden ant, just to give you a picture of what they are. So they are a central place forager, which means they use multiple sources of information to find their way around their environment. They are widely spread throughout Earth. They are found in North Africa, Western Asia, Europe, and North America. So they have sort of a caste system of dynamics where there are 3 different castes. So there are workers who are sterile females, and they maintain the nest, they forage for food, and then they raise the young, so the larvae. And then there are the fertile males, and their only purpose in the colony is to mate, and the queen, whose only job is to lay eggs with the fertile males and feed the larvae when they are very young. So the life cycle of Lasius niger is for about 1 to 2 years, and they are photometabolous insects, which means that they have a true pupal stage. So they'll go from eggs to larvae, then they'll pupate, and then they'll be full adult ants. So their reproductive cycle lasts for 2 to 3 months, and in this 2 to 3 months, they mate, and then afterwards the males are eliminated from the colony because they have no other purpose. So Lasius niger's pheromone trails characterization. So the main purpose of these pheromone trails is to lead the colony to food sources, but they have other purposes such as finding new nests, so they will lay a trail from old nests to a new nest so that the colony will follow. They can recruit others for conflicts, so if they are fighting with, say, another colony about resources or territories, they can use pheromone trails to get more ants up there. And as retrieving signals, so if they are losing the fight with another colony over resources, they can leave. And there is a very characteristic trail laying sequence. So the first step of laying pheromone trails is to press the rectal end of their abdomen to the ground, so like near where like the butt would be. So, and then they'll walk a short distance with their rectal end on the ground, and then they'll pick it back up, and then they'll walk a little bit more, and then repeat the process. So the social systems of Lasius niger, they are a hive mind, so to speak. So they have a collective incentive to grow up with a colony. So there are no individual interests really in Lasius niger colonies. They all just work for the betterment of their colony. So for example, all worker ants will work to collect food for the entire colony. So they will also use both personal and social information in foraging, and this is for the optimization of their foraging experience. So, for example, scouts and recruits, that is combined social and personal information. So a scouting ant is an ant that is actively searching for food, and once they find food, they will lay a pheromone trail back to their nest. That's when they become a recruit. They recruit these other ants to come to the food source, and then they will also come and feed from the food source and go back. And another example is naive and experienced ants. So experienced ants are ones that have fed from a food source, and they will recruit these naive ants to come eat from the food source so that they know where it is too. So foraging trails and sucrose concentration. So Lasius niger shows preferential trail laying to higher quality food sources. So in an experiment to see if they would lay more pheromone trails to higher concentration sucrose food sources, they would set up, let's say, a 1 molar sucrose concentration versus a 0.25 molar sucrose concentration. They would divert more labor to the higher sucrose concentration so that more ants can eat more efficiently. So they will also divert labor to better and more accessible food. So if there's something blocking the way of a food source, they can and will divert food sources to a different, or divert recruits to a different food source. So it is clear that they can differentiate between food sources that are better quality, and they can make collective decisions to divert these resources. So positive feedback and trail laying, this is a sort of loop in these trails and Lasius niger's behavior. So it begins when a scouting ant finds a food source. So Lasius niger will never lay a pheromone trail from their nest to a food source. At first, they must eat from the food source in order to lay the pheromone trail. So they will lay their trail from the food back to the nest, and then they will recruit other ants in the colony to come and forage. So once these recruits also eat from this food source, they will start to lay trail back to the nest and recruit more ants. So it has this sort of like buildup effect, so it gets stronger and stronger over time. So this is a good system if they have a very good food source to eat from, but it can cause problems. Some of these disadvantages include if it's very hard to break this trail if something else that is better is found. So if they need to divert resources elsewhere because they found a better quality food source, or this food source is degrading, they can't really do it because recruits of a better resource, they will lay pheromone trails, but they can't really compete with this already formed very strong trail. So it leads to the colony focusing on a lower quality food source even though there is a better source available. So there are some solutions to this, one of them being negative feedback. So it allows for flexibility in foraging. So once an ant is familiar with the trail, they will stop laying as much pheromones to it. It's like when you've learned a route to somewhere, you don't have to use GPS anymore. So after approximately 47 minutes, according to studies, these trails will begin to degrade. And so if a better food source is found, they can overpower the old trail and make it to where new ants can come to this new food source and feed, and not rely on that old source. Another way to control like overcrowding and positive feedback is with the crowding negative feedback effect. So this is when ants will use less pheromones when they encounter other ants in their path head on. So if they are going on a trail and they meet other ants or things that they perceive as ants, they will lay less pheromone trail because it is understood that ants are understanding where this pathway is. So the way that Lasius niger recognizes themselves, amongst other things, is the particular hydrocarbon, which is just a compound that is found on them. So in a lot of experience, they'll take little glass beads and just kind of coat them in the CHC, and ants will perceive these glass beads, as other ants, so they'll stop laying trail when they meet them. So, and to compound on that, narrower trails also leads to less pheromone deposition. So if they are physically crowded on the trail, they will not deposit as much pheromone. They also will minimize travel distance in foraging. So Lasius niger will mark 2 to 3 times more frequently on trails that are shorter compared to like long winding trails. So if they only have to travel 10 centimeters one way but 20 centimeters the other way, they will mark more on the 10 centimeter path to conserve energy. So there also, it's been proven that they will choose the path that diverges less from their original path. So if there's a bifurcation in their path that is 10 degrees versus 20 degrees, they will follow the 10 degrees one because they understand that that is the shorter, better, more efficient path to take. So different sources of information. They don't just use these pheromone trails. Lasius niger actually can see, which is not universal for all ants. Some ants are blind, but they are not. And these collective pheromone trails are not always the most accurate information to use. So like in a positive feedback loop, it might not be best for them to follow that trail. So they can combine other sources of information to make the most accurate decision for the colony. So Lasius niger actually can use their sight to memorize routes based on visual landmarks. So these landmarks they can see, and they don't necessarily need pheromones in order to see these trails. So it is even proven that they are very dependent on their sight. So if you lower light levels, ants can't see red, so if you put them in like a red room, and you can observe them not being able to find their way around if they don't have like a pheromone, like a straw pheromone trail, because they can't see their landmarks. Okay, and then individual memory and fixing mistakes. Lasius niger is capable of fixing their mistakes when laying trail. So if a food source like moves while they're foraging, they will rely on their individual memories to get there. If they get to the place where they think the food is and it's not there, they can go back, and once they find the food source, they'll lay more heavily back to the nest so that they don't follow the old trail again. And there is a proportionate relationship to L. niger's confidence in their decisions and the amount of pheromone that they deposit. So if they are very confident where they are going and they know where the food source is, they will not, or they will deposit more trail because they know that the food source is there and they want more ants to come eat from it. So if they're not confident, they won't trail as much. An implication of my research found is chemical communication is found throughout all taxa, pretty much. So studying a simple colony such as Lasius niger can help us really understand what is happening with these chemical communication methods. So understanding how different information input can sort of play with these chemical information systems can strengthen our understanding of interpersonal relationships within taxa throughout the biosphere. However, not all forms of communication is well studied. So for example, there are some species of ants that use geomagnetic fields to guide themselves. This is also seen in birds. It's not very well understood, and we don't know exactly if Lasius niger can do the same. And these are my resources. If you want, I can give you a better list that's not that tiny, but I feel like I had to put them all there. And then I would like to thank Dr. TJ for mentoring me with this, and then I'd like to thank all of you for listening, and I'd like to thank the biology department for giving me this opportunity.
Questions for our speaker?
What led you to be interested in this, and what are you going to do after you graduate?
What interested me about Lasius niger is I've always liked the fact that ants sort of always work together in this colony, and it's not like personal interest, which is very rare in the animal kingdom to not see something that is personally interested. They only work for the colony, so I wanted to see, and the chemical trails were always very interesting to me, that they can just follow some pheromones and find the food, but if you break that, they are lost. After this, I would like to probably go to graduate school for anthropology, so I'm very interested in salamanders, and I'd like to study them.
Very cool song. I'm sorry.
Thank you. Yes.
So is there like chances that what'll happen is there'll be a pheromone trail and they harvest all of the food resources from that area, yet ants still continue to head back to the same spot even though it's all gone? And does that happen a lot, or is that sort of a small case scenario?
I would say that if there wasn't a negative feedback loop within in place, so if they were, say, following this trail before the 47-ish minutes, that sort of takes for the pheromones to decompose, they could very well be going to somewhere for food that there is no food. Do you know the
So back to the 47-minute question. On your slide, I may have misunderstood. I thought you said, when you say the trail degrades, you meant the pheromone starts to degrade. The trail keeps going until the food source is gone? Or because you said they also stop laying the trail. So I guess I was just kind of curious as to how long the trail itself lasts as opposed to how long the pheromone, because I thought so long as the ants were going back and forth, they continually putting pheromones down on the trail.
They will, if they're like just traces of the pheromones, they'll keep going, but they pretty much solely rely on the pheromones. So that statistic is based on a trail being laid, the ant being removed, and then timing like how long it takes for it to degrade completely.
Okay, so that's just the pheromone trail. Okay, that makes sense.